All right, let's look at the homework 14.8, problem number 6. All right, so we want to find the try to find the maximum and the minimum of this given function, subject to two given constraints. All right, so let's do that. All right, so we take the gradient of f, so it's partial with respect to x is 1, partial with respect to y would be 2, and the partial, there's no z, so it's going to be 0 there, right? And the partial of z, and it's 1, 1, and the partial with respect to z is going to be 1. All right, and the the gradient of h, partial with respect to x would be 0 because there's no x. Partial with respect to y is 2y, and a partial with respect to z would be 2z. All right, so let's check the answer, submit. All right, it came back and looks like we have part 1 correctly. All right, let's look at part 2. All right, so setting the gradient of f to the lambda times gradient of g plus mu times gradient of h. All right, so here 1 is equal to 1 times lambda. All right, how do you write the lambda? I don't think it spells it out. Oh, that's not it. Okay, got it. Lambda plus mu times, let's see, 0. So it's actually just a lambda. Shoot. All right, so we got that. All right, looking at the second component, 2 is equal to lambda times 1. So lambda. And then you have 2y mu. So plus 2y and mu. All right, so we got that. All right, and the last one is 0 equals lambda, all right, times plus 2z times mu. All right, so let's submit. All right, it came back and looks like we got part 2 correctly. All right, let's look at part 3. All right, so lambda is already equal to 1, so we know that. And then we want to find the mu y, so mu y is right here. All right, so this is 1, so we subtract 1 from both sides, so it's going to be 1 is equal to 2y mu. So they divide by 2, so it's going to be 1/2. All right, and mu z is right here, and you have lambda is 1, so put it over here, negative 1 divided by 2, so it's going to be negative 1/2. All right, let's submit. All right, I came back and looks like we got the part 3 correctly. All right, so let's look at part 4. Last two equations, so those two, tells you that the y is equal to negative z. All right, so yeah, you can just divide through by mu. Then we get that. And then if you plug y equals negative z, so negative z plus z cancel out. So we know that the x must be equal to 1. So we have x equals 1. All right, submit. All right, I came back and looks like we got part 4 correctly. And let's look at the part 5. All right, so substituting y equals 1 over 2 mu and z equals negative 1 over 2 mu into this equation. All right, so one of the constraints. All right, then you're going to get the mu is equal to, all right, I think I'm going to have to do some work on a paper, so hold on. All right, so we just need to plug this guy in here and plug this guy in there. All right, so if you let's say square that, you're going to get the 1 over 4 mu squared and plus negative sign doesn't really do anything because it gets squared anyway. So it's 1 over 4 mu squared, which is going to be equal to, it's going to be 1 over 2 mu squared. And we have to set that equal to 1, all right? So if you take the reciprocal of both sides, you have a 2 mu squared is reciprocal 1 is still 1. And then divide through by 2 to get the mu squared is equal to 1/2. So by taking a square root, mu is going to be plus or minus square root of 1/2. All right, so let's type it in. So we get here plus or minus square root of 1/2. Right? We therefore say y equals square root of 2 over 2 because we can just plug the mu back in here. And the z is going to be just a negative version of the same thing. So it's going to be negative square root of 2 and over 2. Right? And let's see, and y equals negative square root of 2, then it's going to be positive square root of 2 over 2. Right? So let's submit. Alright, it came back and looks like we got part 5 correctly. Alright, so let's look at the part 6. Now we have the possible extreme value. So it's 1 comma negative square root of 2 over 2 comma negative square root of 2 over 2, and 1 comma negative square root of 2 over 2, and the positive square root of 2 over 2. Right, after evaluating f of x comma y at this point, we find the maximum occurs at, right, so we have to actually evaluate these, right? So hold on a sec. Alright, so evaluating these, so f of 1 comma square root of 2 over 2 comma negative square root of 2 over 2. So that's going to be 1 here and multiplied by 2, so it's a square root of 2. Alright, the other point is f of 1 comma negative square root of 2 over 2 positive square root of 2 over 2. Right, so 1 minus square root of 2. Right, so this is going to be the maximum, and this guy is the minimum. Right, so let's answer that question. Alright, so part 6, sorry. So the first one gives you the, let's say maximum A, then B is going to be minimum. Alright, so submit. Alright, I came back and looks like we got the part 6 correctly. Alright, last part. Therefore, we can conclude that, let's see, we want the maximum value. So maximum value is 1 plus square root of 2. And the minimum value is 1 minus square root of 2. Square root of 2. Alright, so let's submit. Alright, it came back and looks like we got the last part correctly as well. Alright, that's it. I hope that this was clear.